the guidelines of the technical report, we have very nice algorithm. And this algorithm will try to maybe go over this. It's almost the same fashion like in our keyboard. And it is going from the geometric concentration. We need to assess in certain sequence. One heart, the same like this heart, we should be given one heart, and then abdomen, brain. So abdomen, we need to assess certain things. And today, unfortunately, there is no time for presentation. Maybe I should just show you a few slides in the presentations. What you need to see in each work is specific things. So today, I will just explain the basics of ultrasound. Probably for others who don't have good experience, they need to know what's black, what's white, what's gray. So in this workshop, we'll discuss the basic in-organ assessment in the crashing infant by ultrasound. And we have specific organs, lung, heart, abdomen, and the brain. We see the steps of the crashing report. So that we publish in different articles. The crashing in different report. That's different from the American Academy guidelines. We have the Russian excellent consensus group on the ultrasound aspects in the crashing unit. That's different article. Also, it's open access. You just if you can get it from Google without any special payment for access. And we have 6 didactic sessions, but I will probably not go through all of them. So there is a crashing unit protocol. Going to ultrasound for systemic assessment of the crashing unit, expert process assessment of the international crashing unit working group. So we have 14 from 4 continents. We agreed on a certain sequence, and I use the same sequence of the American Academy guidelines. This is almost the same way of assessment from lung, abdomen, brain, and heart. So we need to understand the basic of ultrasound first. That's very important if you are really new to the ultrasound as a technique. So at the end of this lesson, you can demonstrate the physics of ultrasound, demonstrate the types of ultrasound groups, and how to select the group, and how the ultrasound work, and demonstrate the ultrasound language. I'll try to do that in 15 minutes. So the physics of ultrasound. Ultrasound is waves. And it is ultrasound means because it's beyond our ear to detect. So our ear can detect between 20 to 20,000, that's maximum. But ultrasound we are using million of hertz per second. So each wave above a baseline and back to the baseline is 1. And then we have 1 million per second of each of these waves. It means 1 megahertz. So this is the range that we are using. And the more megahertz or more frequency, now we call it frequency, it means you can reach the superficial depth. Why? Because in higher frequency, the duration is shorter. It is high frequency, so the duration of each cycle is short. It means that you can see the near object. When you have a wide wave with low frequency, you can see the deeper object. So we have 2 types now of ultrasound waves. We have low frequency with deep penetration, and high frequency with superficial penetration with high resolution. That's why ultrasound in US is beautiful, very nice. You can see where the details. In adults, you see the things very as shadows and not very high quality. In units, everything is nice and clear, relatively, compared to adult, which is nice. It is very high resolution, superficial penetration for high frequency, deep penetration, low resolution for low frequency. So how the machine does this job? So the electricity that we have is the frequency for any TV or any kind of electric device. There is a fixed frequency. All over the world, it's 50 to 60. If you check any kind of device, 50 to 60 hertz, not megahertz, hertz. So the machine will convert the commercial electricity into high frequency, which is as per the requirement, 10 megahertz or 20 or 10. So 10 megahertz means 10 million. So convert 50 to 10 million. So just to imagine the machine is really, that's the most important function of the ultrasound machine. Now we'll come to the ultrasound terminology, echogenicity. Echogenicity means there is a brightness. Anything echogenic means bright. So when the ultrasound, there are three things, either black, white, or gray. There is no third option. Color Doppler is different mode. We're talking about two-dimensional ultrasound. There is black, white, or bright, and gray. So we call black is hypoechoic, bright is echogenic. So in this presentation, short presentation, we need to understand the language. What's bright? When we see anything bright, what could be the bright things in the ultrasound, or what could be the hypoechoic or black? So it depends on the amplitude and the intensity of the ultrasound wave returning to the transducer. So the ultrasound group sending four ultrasound waves to the volume or the organs. So the ultrasound waves emerge from the ultrasound group to the body, and some ultrasound waves will be reflected back, some ultrasound will be disappeared, and the ultrasound machine only detects what's reflected back. So if the reflected back too much echoes, then we see that light. If there's less number of echoes, that will be gray. If there is no echo reflected at all, it will be black. So high intensity returning waves is bright, white. Low intensity returning waves is gray. Absence of returning waves will be black. So we need to understand more how it happens. Before we go further in the language, we have main three types of books. We have the convex. In units, we are using microconvex, like small, tiny microconvex for the brain. Could be used also for the abdomen, could be used for lung, for the diaphragm assessment for intestine. But we prefer to use the linear group for the lung, and also for the intestine because it's a very high frequency and very sensitive. And in the market now, we have as high as 30 gigahertz. Some groups 30 gigahertz. You can see, if you put it in your finger, you can see your finger bend. So it's very, very sensitive and very spontaneous. And we use it also for vascular assessment for insertion of the peripheral thick line, percutaneous line, in premature infants. That's very tiny, small, we are talking about millimeter depth for the vascular access guided by ultrasound in premature infant. And for interventions as well for the lumbar puncture, we are using ultrasound to detect the most, the highest collection of CSF before we do the lumbar puncture. And easy and simple. Also for vocal cord assessment. If we have infant with vocal cord paralysis or vocal cord weaknesses, it's easy to detect the vocal cord movement by ultrasound. So these are very nice applications. You just have the probe and you play with the probe and you can scan a lot of things. And all of these things, they are not really applications for radiologists. Most of these applications, they are not really familiar with them. They are not familiar with the interventions, they are not familiar with the vocal cord probably, the ultrasound. I mean, most of them, but some of them we can do that for sure.
And now we have everything in addition to that for us.
Yes, yeah, we'll come to that, yeah. For example, now we have the standard ultrasound is a standard to assess for neck, not X-ray. For example, if you have infant with abdominal extension or vomited with blood stool, and we are suspecting that the X-ray came back, there's nematosis. You can silence, but the infants clinically probably will, CRP is low.
And I have one of the Dr. Amani Reda, she's very expert, she's doing this also for years.
It's not the yeah, very good. Yeah, that's very helpful. So, X-ray is not very sensitive, and it is about 50% sensitive. So the ultrasound is normal, even the X-ray is showing nematosis, will stop you. But again, the data should be clinically well.
كان في اونلاين ورك شوب على الديفرنس ما بين الاكس راي وكان ساعتها الالتراساوند ايه والبيبي كان دايجنوز ايه اللي هو انيشيتيف بودي تبع الورك شوب اللي حضرتك بتعملوها اللي كانت اونلاين فكان في حاجات كتيره جدا كان الاكس راي فيها فيكس لوب وكان دايجنوز از نك وفي الاخر الالتراساوند طلع كومبليتلي نورمال والبيبي ستارت فيدنج اند nothing happened.
That's very frequent. That's happening almost on a weekly basis. And some of these cases not 100% normal. Sometimes they have full routine allergy. If food routine using the price, which is a all the names can be managed.
Do you now vocal cord training? Established.
That is an all training program for the
دي تبقى جود تول علشان السynchronization with non-invasive ventilation.
Yeah, some things were not related to relating CPAP, or not relating non-invasive. It could be related to weakness in the vocal cord.
Yeah, I have
Or sometimes CPAP related, we can remain off CPAP for a long time, and or post intervention like cardiac surgery or post before PD ligation or not during PD ligation. 30% of the infants undergoing PD ligation they might have vocal cord collapse. So that's very helpful too, and easy to diagnose as well. So we have types of media. That's very important slide. How many types of media we have in our body? Air, fluid, or tissues. Anything else? Yes. And tissues could be solid or could be. Yeah, we're talking about natural. So we have air, and air is any of the ultrasound. And for that reason, we cannot see the lung as an organ, three-dimensional organ. We see artifacts. We must translate artifacts into pathology. So we'll see only artifacts or translated artifacts. And the fluid is the lever. The ultrasound, the ultrasound has fluid. That's why you see black and you see anything underneath. And how to differentiate between the black as artifact and the black as fluid, we'll consider that later in more details. Soft tissues is a clinical ultrasound, and more soft tissues easy to pass ultrasound. Harder tissue will be reflect more ultrasound. So the harder the tissue, the more echogenic. The softer the tissue means more fluid contained, the more gray or more hypoechoic or more black. And we use this feature to diagnose tissue that became more ischemic. For example, kidney become more ischemic would be more echogenic. If the kidney is normal, would be hypoechoic. And the same intestine is echogenic or ischemic. Bone can reflect the ultrasound, so we cannot see anything underneath. So reflect sounds and slight absorption of sound, but no pass, which we call it acoustic shadow. So we can see only tracing of the bone and anything below as a shadow. We call it bone shadow or acoustic shadow. So let us see that in more clarification. So now I have the black. If you see black in the ultrasound, it's one of the three options. There is no number 4. Now one of the three options. So black would be ultrasound passes easily through, which is fluid or blood. So if you have a blood in the heart, will be seen black. The blood in the vessel will be seen black. Moving fluid or non-moving, any fluid will be seen as black. Easy to see what's deeper. So how to differentiate this black is fluid or artifact? If you can see underneath or around the fluid, it is fluid. Because as I mentioned, the fluid is allowed within the ultrasound pass, so anything around will be seen by ultrasound easily. If the black is different thing, will not be seen any underneath structure. So it could be one shadow, cannot see what's deeper, will be just as a shadow. So I think now it's easy to differentiate between both. What's the third option shadow? We know the fluid air interface. What the fluid air interface is in our body? The pleura. Pleura is a thin ring of fluid between the visceral python and below the pleura we have air, normally. In normal life we have air or pneumothorax, and we have air in between the 2 layers. In this situation, we'll see black, but we'll see black with just artifacts. There is nothing that you can see underneath because it's not fluid.
But
So,
inside the ventricles, you see the blood that's very efficient.
yeah, that's number 1 because it's blood. Right?
You can see black. That's a moving blood. If it is extravasating, it will be
Yeah. If the blood is hemorrhage, it's different. So you mean the ventricular hemorrhage?
Yeah.
No, it will not be black. It will be unless it is like.
Just to clarify this when we present, so it's say white is white when you see
Yeah,
inside
I'm coming to that as
yeah.
well. Yeah, so shadow below the fluid air interface. What's black also? Yeah, I mentioned that it is the fluid interface is a pleura. It can be also the intestinal wall. Because you may see air inside the bowel, so you see the interface as an intestinal wall. in this equation also we'll see only outcomes. So what's gray? Gray, any organ with blood supply will be gray. Liver, kidney, spleen, brain will be gray. And it is different grades of gray. It can be bright or brighter if the blood flow is less, or can be more gray if the blood flow is high. For the intestine external wall, you can see layers. You can see 5 layers of the intestine according to the blood. You can see the cirrhosis is more oncogenic, musculosa and mucosa is more hypochoic because they are receiving more blood. And submucosa is more oncogenic. So that's why you can see the layer of intestine, and it is a sign that the intestine is healthy. Because when you see that everything is ecogenic, it means that there is no blood supply to the musculosa. Now what's white? One of the 3 options. Number 1, clotted or hemorrhagic blood. As Monica said, it is a blood inside the ventricle, will not be seen black. It is tissue. The clotted blood is not fluid anymore, it's tissue. It's blood.
No, I'm asking
Cardiac
because
ventricles.
Yeah, that's the same. So it is in the hemorrhage inside the ventricle is clotted blood. That's why you see it as white. Fluid interface itself. And the black is what's underneath, what's below the fluid interface. But the fluid interface itself it is white, right? Like pleura, the pleural line will be white, ecogenic. And then very ischemic organ will be also ecogenic. So we have examples of that. So this slide probably is enough for this presentation. That's just they explain the language of the ultrasound in details. Now we have some examples. So what's inside this organ here? Fluid, yeah, and this is blood bladder, and this is it. And you can see what's underneath even more clear than the rest of the image. We call it acoustic enhancement. Because anything under fluid, the ultrasound will pass very clear and will see everything is clear. So you have some external lobes below the gallbladder clear. And then we have very ecogenic bowel here. Ecogenic bowel is the fluid because of the lymphadenopathy. Here we have one ultrasound. We have the, like what we have seen in the first presentation with Monica. We have this bit here from the left side. This bit here with the red shell and the black is nothing you can see. And then the process space, you can see the part of the pleura. The pleural line of the fluid here interface. And we have the interstitial fluid. And then we have two kidneys here, the kidney hypochoic and the kidney ecogenic. This kidney will enter with HIV. And we have very ecogenic and loss of corticomedullary differentiation, which is also part of the normal kidney. Here the cortex is ecogenic and the medulla is hypochoic, receiving more blood. Here the differentiation is lost. And then we have hemorrhagic blood in the protophalamic group. So we have this sagittal view of the brain. So you have the thalamus, and you have the caudate nucleus in between. You have the protophalamic group should be a groove. Now we have a lump of hemorrhage here. So this hemorrhage, and you have also some hemorrhage. So that's great to IPH. You have except of the hemorrhage and some blood clots sitting at the pseudo hormone. In summary, now we understand the ultrasound, how the ultrasound works, ultrasound physics, and how to identify the language of the ultrasound. And thank you very much on that use of the Okay, now what's the time now? 12. I think probably the next step we divide into the groups.
بس عاوزة بريك واحنا قاعدين وبعدين هم